Okay, everyone. A pleasant morning to all of us. I hope you are okay right now. So today we will discuss about the fiber optic sensor. So in the year 1960, laser light was invented, and after the invention of lasers, researchers had shown interest to study the application of optical fiber communication system for sensing, data communications, and many other applications. Subsequently, the fiber optic communication system has become the ultimate choice for gigabits and beyond gigabits transmission of data. This type of fiber optic communication is used to transmit data, voice, telemetry, and type of fiber optic communication is used to transmit data, voice, telemetry, and video over a long-distance communication or computer network or LANs. This technology uses a light wave to transmit the data over a fiber by changing an electronic signal into light. Some of the excellent characteristic feature of this technology include lightweightness, low attenuation, smaller diameter, long-distance signal transmission, and transmission security, and so on. Significantly, the telecommunication technology has changed the recent advances in fiber optic technology. The last revolution occurred as designers to combine the productive results of optoelectronic devices with fiber optic telecommunication devices to create fiber optic sensors. Many of the components associated with these devices are often developed for the fiber optic sensor applications. The ability of the fiber optic sensor has increased in the place of traditional sensors. The wavelength shift can be calculated using a device optical frequency domain reflectometry. The time delay of the fiber optic sensors can be decided using a device such as an optical time domain reflectometer. So what is the fiber optic sensors? The fiber optic sensors are also called as optical fiber sensors use optical fiber or sensing element. These sensors are used to sense some quantities like temperature, pressure, vibrations, displacements, rotations, or concentration of chemical species. Fiber optic sensors also frame for insensitive conditions, including noise, high vibration, extreme heat, with unstable environments. These sensors can be easily fit in small areas and can be positioned correctly wherever flexible fibers are needed. So this is the general block diagram for fiber optic sensors. The general block diagram of fiber optic sensor consists of optical source such as light emitting diode, laser or laser diode, optical fiber sensing element, optical detector and processing devices such as optical spectrum analyzer or oscilloscope. These sensors are classified into three categories based on operating principles, sensor location, and applications. So, types of fiber optic sensor. So, first one is based on the sensor's location, based on the operating principles, and based on applications. These sensors can be classified and explained in the following manner. So, based on the sensor location, you have two types: intrinsic fiber optic sensors and extrinsic fiber optic sensor. And also based on operating principles, you classified into three. First one is the intensity based, phase based, and polarization based. And third and lastly is based on application. chemical sensor such as chemical sensor, physical sensor, and biomedical sensor.
Based on the sensor locations, intrinsic type fiber optic sensors. In this type of sensor, sensing takes place with the fiber itself. The sensors depend on the properties of the optical fiber itself to convert an environment actions into modulations of a light beam passing through it. The sensors depend on the properties of the optical fiber itself. Here's one of the physical properties of a light signals may be in a form of frequency, phase, polarizations, intensity. The most useful feature of the intrinsic fiber optic sensor is it is provide distributed sensing over long range distance. Extrinsic type fiber optic sensors. It is a type of sensors. The fiber may be used as information carriers that show the way to a black box. It generates a light signal depending on the information arrived at the black box. The black box may be made of mirrors, gas, or any other mechanism that generates an optical signal. These sensors are used to measure rotations, vibrations, velocity, displacement, twisting, torque, and accelerations. The major benefits of this sensor is their ability to reach places which are otherwise unreachable. In other words, extrinsic type fiber optic sensors, the fiber may be used as an information carrier that show the way to black box. The second is based on operating principle. Intensity-based fiber optic sensor is an intensity-based fiber sensor require more light, and this sensor uses a multi-mode large core fibers. Phase-based fiber optic sensor. These type of sensors are used to change emitting light on information signals wherein the signal is observed by the phase fiber optic sensor. When a light beam is passed through the interferometer, then the light separates into two beams, wherein the one beam is exposed to the sensing environment and the other beam is isolated from the sensing environment, which is used as reference. Once the two separated beams are recombined, they are get in the way with each other. The most commonly used is interferometers are Michelson, Zeder, Zagnap, grating, and polarimetric interferometer and Arshow. Next is polarization-based fiber optic sensor. Polarizations-based optical fiber are important for a certain class of sensor. This property can be simply modified by various external variables, and thus this type of sensors can be used for the measurement of a range of parameters. The optical setup for the polarization-based fiber optic sensor is served as sensing fiber. Then, the phase difference between the two polarizations state is changed under any external disturbances such as stress or strain. This according to the external disturbances. The output of polarization is changed. Thus, by considering the output, polarization state the next end of the fiber. The external disturbances can be detected. Third is based on applications. We have chemical sensor. A chemical sensor is a device which is used to transform chemical information into form of measurable physical signal that is associated with the concentrations of the certain chemicals. The chemical sensor is an important component of an analyzer and may include some devices that perform the following functions. First, signal process, sampling and data processing. An analyzer may be an important part of automated system. We have biomedical sensor. Biomedical sensor is an electronic device that is used to transfer various non-electrical quantities in biomedical field into easily detectable electrical quantities. Due to this reason, these sensors are included in the healthcare analysis. This sensing technology is the key to collecting human pathological and physiological informations. Physical sensor. A physical sensor is a device that is made according to the physical effect and nature. These sensors are used to provide information about the physical property of the system. These type of sensors are most signified by sensors such as photoelectric sensors, piezoelectric sensors, metal resistance strain sensors, and semiconductor piezo-resistive sensors. Characteristic of fiber optic sensor. The optical fiber sensors have unique advantages such as high sensitivity, immunity to electromagnetic interference, small size, lightweight, robustness, flexibility, and the ability to provide multiple of distributed sensing.
Small-scale fiber optic sensors have found some utility in textile sensing system for sensing strain and fiber binding. They are inherently suitable for textile integration because they can have outer fiber diameters of 300 ohms or less. They also have advantages over the aforementioned sensing fiber types because of their electromagnetic immunity. For most applications, the maximum distance of any type of fiber optics cable is around 62.14 miles or 100 kilometers. However, some applications require long distances, and special cables with special dispersion compensating fibers can extend this to more than 200 kilometers. The application of fiber optic sensor is used in varied range of applications such as measurement of physical properties such as temperature, displacement, velocity, strain and structures of any size or any shape. In real time, monitoring the physical structure of health, buildings and bridges, tunnels, dams, heritage structures, for night vision camera, electronic security systems, partial discharge detection and measuring well loads of vehicles. So before we end, thus on the overview of fiber optic sensors and application has been discussed. There are many advantages of using fiber optic sensors for long distances communications that include small size, light in weight, compactness, high sensitivity, wide bandwidth, or etc. All these characteristics makes the best use of fiber optic sensor. So before we end our discussion, we have a video to show you.
Fiber optic sensing recently becomes a popular alternative to traditional electric sensors. It consists of an optical interrogator sending infrared light down the core of an optical fiber. As white light, meaning all colors of the visible spectrum, travels down the fiber, it passes through a fiber fragment or FPG. This is a series of optical filters that return certain wavelengths or colors while letting others pass through. This happens by periodically altering the refractive index of the fiber, dictating which wavelengths pass. External factors, such as vibration, will cause a shift in the wavelength of the reflected light. These variations can then be translated into physical engineering units such as amplitude, temperature, and strain. Because all FPG sensors are based on measuring within a selected wavelength or color range, it is possible to daisy-chain multiple sensors on a single optical fiber. Unlike conventional electrical sensors, FPG sensors are non-conductive, electrically passive, and immune to electromagnetic interference, making them a safe and reliable alternative in environments subject to noise, corrosion, or high voltage.
Okay po, that's it for our short overview in fiber optic sensor. Thank you everyone and have a good day.
And this is example of fiber optic sensor.